So now NumPy stands for numerical Python. Panda stands for panel data. Okay. Now, what is the advantages of using NumPy? NumPy is built on top of C, so it's numerically faster. And when you're carrying out mathematical computations, you need speed, right? So let me give an example. If I have a list, say um class 2 equal to this. This is just another way of right of creating a list. Let me say 1, 2, 3, 4, 5. And I do class 2. It will take a while. My collab is connecting. I don't know. Let's just speak to it. Okay. Let me build it the traditional way so that it will this class 2 array. You want to perform some statistical analysis on it. So if I do class 2 dot sum, show me an error. Right. You see that the object has no attributes dot sum. If I do dot mean, show me an error. How do I fix this? I'm going to import numpy. Import numpy as np. Then I change that class to uh, array equals to, should I instantiate it? Let me say new class. New class equal to np dot array class to new class. So you see that it has this array something in front. This is now a numpy array. So if I do new class dot mean now, voila, it finds the mean for me. If I do dot it adds everything together for me and returns the results. If I do dot min max, it does all of that for me. So NumPy allows you to, or is the go-to library for numerical computation in Pandas. Sorry, in machine learning, data science. NumPy is your go-to guy when you want to perform numerical calculation. All right, let's use Calculus. Let's follow these templates. Um, how models work. If what I'm saying is something that Israel has said on Friday, let me know so that I can just um, go over that and go to the next one. So, what is machine learning? Does anyone want to try? What is machine learning? That is why we are here. That is the cocoa of the matter. Who wants to try? What is ML?
I think I think machine learning is about, I don't know, maybe like prediction or something. I don't know.
That is part of it. Does anyone else want to try? It's only Blessing's voice having you.
I think machine learning is like it's like a program that is used to predict patterns from data using like the previous data that have been that have been analyzed. Yeah, something like that.
Thank you very much for that word. You mentioned a very key thing, patterns. All right, so the first machine learning definition I was given when I started my journey like 4 years ago was machine learning is a way of programming where you tell the computer to do things, or where the computer learns patterns or carry out things without being explicitly told to do so. So in normal programming, you tell your program that go left, go right, go central, go up, go down, is being stated explicitly the next action to take. But in machine learning, your program learns by itself. So it learns from the pattern from the data which it was trained on or built on. So machine learning is a way of programming where, or is a methodology of programming where your program is carrying out tasks without being explicitly told to do so. Okay, so as overview of machine learning models and how they work. Okay. So now this is giving us a hypothetical scenario saying that your cousin has made millions of dollars in speculating on real estate. He has offered to become business partners with you because of your interest in data science. You supply the money and you supply models that predict how much various houses are worth. So you ask your cousin how he's predicted real estate values in the past, and it says just intuition. But more question refused that he actually identified price patterns from houses he has seen in the past and uses those patterns to build or make predictions for the new houses he's considering. So that is the same way machine learning works. So they are starting with decision tree. Okay, let's start with what was in my mind before was linear regression, which is almost the first model every beginner machine learning engineer uses. But I guess this works too. So machine learning works the same way. We'll start with a model called decision tree. They are fancier models, trust me. Depending on how fast we iterate, I think our program is ending in 2 or 3 weeks. Depending on how fast we can iterate, maybe we can go into deep learning. Then you see all those fancy models like the technology on which ChatGPT is running, transformers and the rest. But if we can't, we'll share resources. Trust me, I have a lot of resources for you to use. Okay, so we'll start with a model called decision tree. But decision trees are easy to understand and they are the basic building block for some of the best models in data science. So for simplicity, we'll start with the simplest possible decision tree. So you can see here, you can see this box and you can see these two trees below it, just like the way you have family tree, mother, daughter, son, like that, decision tree. Trees that affects that contributes to the decision making process. So you see, does this house have more than 2 bedrooms? If no, the predicted price is 178,000. If yes, the predicted price is 188,000. So this divides houses into only two categories, and the predicted price for the house is dependent on the number of bedrooms that that house has. So we use the data to decide how to break the houses into two groups, and then again to determine the predicted price in each group. So the steps of capturing patterns from data is called fitting or training the model. Fitting, when you are fitting or training the model. So the data used to fit the model is usually called the training data, while the data that you use to test how well your data is performing is usually called the testing data. There's also something called validation, train test val, or we can skip that for now. Just what you should have at the back of your mind is that the data that you use to train your model is called the training data, and the data they use to test your model is called the testing data. Now, let me give you a scenario, right? Look at machine learning. I want you to look at machine learning the same way. We are all students. We go to class, we learn, then we write exams, right? So the data that you use to learn for your exam is called your training data. That is the data that you use to learn all the textbooks, resources. That is what you use to learn and prepare for the exam. Now, the data you see in the exam is your testing data. So that data is related to what you read, right, for the exam. But you're not testing your ability to generalize from what that data is, you read, your training data, and use that to predict based on this new test data, the various answers. I don't know if it's multiple choice, if it's theory, but you want you to use that your previous data which you have trained on and make predictions or answer this test data. Is the same way machine learning works. All right. So the details of how the model is fits of how to split up the data is complex enough that I'll save it for later. After the model has been fit, you can apply it to the new data to predict price of additional homes. We'll have hands-on. We have 30 minutes. Hopefully we have hands-on experience. So which of these two trees is likely to result from the fitting of the SD data? So here we have two decision trees, right? So which of these following two decision trees is more likely to result from fitting the real estate training data? Who wants to guess? This is the first decision tree. It has more than 2 bedrooms. If it has more than 2 bedrooms, predicted price 188. If it has less than 178. This is the second decision tree. If it has more than 2 bedrooms, its predicted price is 178. If it has less than 2 bedrooms, predicted price is 188. So who wants to guess which one of these following trees is likely to result from fitting the real estate training data? The first or second decision tree?
The first one.
All right. So why do you say so?
Because obviously there are more bedrooms, it costs more.
Yeah, I just saw the expo is even down, so I just scrolled down. All right, so yes, you're very correct. So this first decision tree captures the reality of life that um houses with more rooms tends to be more expensive. We are all Akokas. We know how the prices of even hostels that we calling 300K, 400K for you, talk less of going outside school where they think you're a cultist and be telling you that 1 million for 1 bedroom apartment, right? So it's logical. If it's 2 bedroom, they'll be going at 1.5. So it's the same analogy. This first decision tree captures the reality of life that it is natural for houses with more than 2 bedrooms to cost more than houses with less. All right. Okay, that is not what they're saying here. So this decision tree on the left probably makes more sense because it captures the reality that houses with more bedrooms tends to sell at higher prices than houses with fewer bedrooms. Now, the biggest shortcoming of this model is that it doesn't capture most factors affecting the home price. Like it's not only bedrooms that affect it. What of things like number of bathrooms, the so maybe this it's not land square area, the square area of the house, the location, is it in Agege, is it in Banana Island, the size, the parking lots, the parking space, all of those things to come into play, right? So you can capture more of those factors using a tree that has more splits. And these are called deeper trees. So a decision tree also considers the total size. A decision tree that also considers size of the house might look like what we see here in this infographic. So you see that same question. Does your have more than 2 bedrooms? If yes, it asks another question. Is the lot size larger than 11,500 square feet? Then if no, predicted price 170,000. If yes, the predicted price is $233K dollars. Then does your house have more than 2 bedrooms? If no, is your lot size larger than 8,500 feet? Square feet rather. So if yes, this is your predicted price. If no, this is your predicted price. So you can predict the price of any house by tracing through the decision tree, always picking the parts that corresponds to that house characteristics. So the predicted price for the house is at the bottom of the tree, which you can see here. And the point at the bottom, this place where we make a prediction, is called a leaf. This lowest part. So the splits and values at the leaves will be determined by the data. So all of this here, your leaves are determined by the data you feed it. The bedroom, number of bedrooms, the parking lot size in square feet. All right. So it's time for you to check out the diagram. So in machine learning, you have to explore your data because consider that you are an accountant. Maybe accountant is too far. Consider you have been hired as a consultant to build a solution for a model for a company. You have to explore what kind of data you are working with. If you remember in our early classes, I said you have to sit down with a domain expert. So there are people that are economics, that are data scientists. There are people that studied philosophy. that is a data science. I know someone that's finished from HKE and is a very good data scientist, right? But if peradventure that person now is contracted with an healthcare agency to maybe model um, um, diabetes and build a model to um, predict whether a patient has diabetes or not. He will not know that someone that's not this philosophy with no background in medicine, he might not know some factors and some nuances which he has to um, consider, right? Or he has to factor in. So that is where he now has to talk to a domain expert. So he meets someone in the company who is into the health sector. Then now ask him that, okay, I'm working on a diabetes project. What are some parameters? What are some features? What are some factors that contributes to whether a patient will have diabetes or not, right? And those are the basis upon which you build the data. In another hypothetical scenario, it's possible that the company just sends you the database they have. So they have records of data. So you don't just go and start building, import SQLN. You have to understand your data, become one with your data. So this is another. So in the data science workflow, this is where EDA comes in again. If you guys remember, we did EDA before, exploratory data analysis. This is where it comes in again. But this time you're analyzing so that you'll be able to build model, a machine learning model that captures the relationships. So you're not building a miss. You're accounting for intricacies depending on the domain or the field you're modeling for. You guys understand that?
Yes.
All right, lovely. So we've used pandas before. So the first step in any machine learning project is to familiarize yourself with the data, understand the data, become one with it. So we use pandas. Remember, I said pandas stands for panel data, and we've seen some hands-on experience with that. So the most important part of a Panda service is data frame. I've seen that similar to a sheet. I've seen that. So as an example, we look at data about home prices in Melbourne in Australia. So in the hands-on exercises, you apply the same processes to a new data set, which has home prices in. I'm forgetting how to pronounce the states. Is it you are? That's how to pronounce it. So the example Melbourne data is are the file paths in Field Snapshot. Or these were okay. Takes me. So you see that this is the data set. If I want to download it, I just download it here. So you can see the people amount of people that has upvoted. So I just upvoted again 1, 3, 4, 5. In calculate as a place where you can see the number of people that has downloaded it. Then you can see now it has different parameters which you can investigate. See, suburb, are you in Reservoir? Are you in Richmond or others? So you see the address here. See that it has 13,378 unique values. See the amount of rooms in those houses. You also have to investigate what does H and U mean. Alright, so that's just good to reach because of the data. Melbourne real estate is booming. Can you find the insights or predict the next big trend to become a real estate mogul or even harder to snap up a reasonable price 2-bedroom unit? So this data is created by Tony Pino, a script by publicly available data posted straight from domain.com.au. He cleaned it well and now it's time for it to analyze it. So the data set includes address, type of real estate, suburb, method of selling, rooms, price, real estate agents, date of sale, and this stands from CBD. What does CBD stands for? So this is practically how you let me see. Address, rooms, type, price, method, seller, dates, distance, postcode. That 159,000 people have downloaded it. Okay. So these are things that you have to becoming one with your data. You must understand each of these features. What do they mean? All right. So that was like distance from CBD. So you see price, not on specific variables, price, sorry, number of rooms, price in dollars, method, property sold, S is property sold, SP is property sold prior, PI is property passed, PN is sold prior but not disclosed, SN is sold not disclosed. So you first have to analyze all of this data, understand what each of these features mean, then you go ahead and build your model. All right, so now this is exploring. So the first thing that they did was, let me just fulfill that right also. Don't have time. So the first thing they did was they copy the file path. But this is the file path in their own local machine. These dots can mean anything. It can be gaming users, then inputs, depending on where the file path. So if I downloaded, just wait for entry. If I download this data set now, let me download it. It is downloaded. So I have to go to, okay, I'm not sharing my entire screen. Let me share my entire screen so you can see what I mean. Um, okay, so this is the data I just downloaded. See that is in downloads. So depending on what I'm working here, I'm going to put it in Colab. Okay, first I have to extract it. As this guy extracted, right? I'm going to be looking for. Okay, so this is the Melbourne data set. So if you want to copy file paths, depending on your laptop, for me here, I can come here, copy as paths. That file path that I copied. So Paraventure was working with a Jupyter notebook, which Jupyter notebook is local, my local machine. If I come in, engineering synchronous, this is my file path. So this place where they have, this will be my, right. So this place where they have this thing, right here, Melbourne file path. That have been my file path. So you now read the data. We've seen these guys before. pd.read_csv and describe print statistical summaries of the numerical columns in your data set. We've seen all of this before. So you interpret the data. You have the STD, standard deviation. The mean is 50%. The max. So this is the mean. 2.93. Blah, 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 blah. 50% should be in media. Yeah. So this is after you sort your data, the numerical data in ascending order in order of increasing magnitudes. So you have all of these guys. That's why your mean is varying from this guy. You know, mean and median are different, right? As data scientists, it's important I tell you guys this in many times when you're doing calculations, it's good to use your median instead of mean because when you have outliers, your mean can be very skewed. So imagine if you have, um, for example, purposes, because this is a common question they ask in data science space. So imagine if you have something like, let's say I have 1 plus 1, 2, 3, 4, 5, 6, then I have 40. Now, if I take the mean of these guys, let me say this is a numpy array, np dot array, so that to do it for nothing should I call it? X example. So if I do x dot mean now, I want me to make it take its first. You see the mean of this guy. Mean is taking all of them, taking the number of observations and dividing by the total number of observations. So you have 1 plus 3 plus 4 plus 5 plus 6 plus 40 divided by 6. You get 9.88, blah, blah, blah. Or if you want to take the median is what? Your middle number. After you arrange them in order of increasing magnitudes. All right, so these are in order of increasing magnitude, so we don't need to worry about that. For your median now, this is 1, 3, 4, 5. This is 6 numbers. So you take 4 and 5 and divide it by 2. That is your middle number. So 4 plus 5 is what? 9 divided by 2, 4.5. That is your median. So many times in your future data science careers, just have it at the back of your mind that the mean is a more robust measure of central tendency, especially when you have done analysis and you've seen that your data set has a number of outliers. Like here now, this 40 is an outlier. What did I do? Share. All right. Stop this game. I don't care. How are you going to? Oh, don't know why it's doing this to me. Mm. So basically, we have to understand the nuances of our data, right? That's why we are doing this. Then after we understand it, we know what each feature, each column is doing, then we can proceed to building our model. It's taking, I don't have time for this, unfortunately. I would have done this with us. But actually, we should do that as an assignment. These are things I've done before, so they shouldn't stress you. So let's look at our building our first machine learning model. So let me share that. Let me share that data with us on WhatsApp. So I've put the data in the group for future reference. The CSV file. All right, let me just explain this. So the reason I'm doing this is that now you can do some further digging by yourself using Calculus. Okay, so first imported pandas as PDE. Then we loaded the data sets from our local system, right? Then we first checked the columns. Remember, these are the columns there: suburb, address, room, type, price, method, seller, date, distance. These are all the columns. So he said you should drop axis with missing values. What is the Meldon data has some missing values, some houses for which some variables weren't recorded. So we'll learn how to handle missing values. Maybe we discuss on how to handle missing values now, right? We discussed on how to handle missing values. We can use interpolation where we can fill them with the mean. You can fill them with a placeholder value. Those are the three common ways to handle missing values. And sometimes you drop those columns that have missing values. But that is not always the best option, because imagine if you have a column that has like 1,000 missing data value and your entire data set has like 2,500 rows. You have already done, you have lost a lot of information for your model that could have been valuable to it in other columns. That's why it's not always the best to drop. But when you see that they are not much, just drop it. So the Meldon data has some missing values. We'll learn how to, I think we've done this already. Or can you guys correct me if I'm wrong? We've done how to handle missing values. Haven't we?
Yes, yeah.
Guys, can you? Olamide, was that you?
Yes, I said yeah.
Oh, okay. All right. So your Iowa data doesn't have missing values in the columns you see. So we'll take the simplest option for now. We'll drop houses from our data. So this is dropping. Drop now means drop missing values. That's what this method is doing. Right. So we are dropping axis. Remember your data sets. A data frame is made up of rows and columns. Rows and columns. Now your rows is axis 0. Your column is axis 1. So this is dropping missing values along rows. So there are many ways to select a subset of your data. I think we looked at some of that now. Might even be in this notebook. Let me carry this. No, come out, come out. Wipe is blurry here. All right. Might even be in this notebook where we're subsetting data. Yeah, this was the example of subsetting where you're picking just a particular number of your data. That is subsetting. We're just picking a particular part, like data that fulfills some specific condition that we have specified. So selecting the prediction target. Now, the target is the column of interest, what you're trying to predict or what you're trying to classify. That is your target column. So now we are trying to predict our house prices. We have, okay, these are the number of columns in our data, right? These are the number of columns. Can someone intuitively tell me what is our target um, column in this our data sets? In these columns that we have, what is the target column? Or where is our target variable? Time is going. We have like 2 minutes left. So just try, even if you're not correct. I want to hear your voices.
Bathroom, yeah, built. Bedroom 2, rooms.
Okay, thank you for that. Does anyone else also want to try really quick?
I think the address would also be part of And the land size also.
All right, so thank you guys for trying. Even though none of you got the answer, but I appreciate the effort. That just means that it has given me some context I need to explain again and explain better. So when you are building machine learning models, you are trying to, a lot of time, when I asked you at the beginning, a lot of you said predict something, right? You are trying to predict something. That thing you are trying to predict is your target variable, or that thing you are trying to classify is your target variable, right? So if I have a number of um have some patients. I'm trying to build a model to predict diabetes, and I have factors. I have like number of hours exercise a week, their weight, their diet, and I have diabetes. Does the patient have diabetes? Yes or no? So if I have all those columns, what is my target variable? What is my target column?
To know if the patient have diabetes.
Exactly. So now taking that same analogy, we are trying to predict house prices, and we have some factors that contribute to that house prices. We have the address, number of rooms, number of bedrooms, the location, the year built, the land size. But what is our target variable?
The price.
Exactly. So the price is our target variable. So that is what we're doing here. So when you are training data, we always use X and Y. We're not doing it. We always use X and Y, where X is your training data and Y is your target data. So what do you do if you have trained your model on a data, right? For the testing data, you drop the y-axis because you don't want your data to be learning the prices. Already have the price. If you don't drop your y-axis, it's analogous to making students write an exam, but you give them the answer. So they're just writing it from the answer you give them and putting it in their exam scripts or sheets, or whatever we call it. What do we call it? Answer sheets. So it's as if you gave them the answer and they're now putting it in the exam sheets. And we don't want that. That is why we drop this. So here, you see that we're selecting the target variable, which is price. And this method is called chaining. I think we've looked at that before. We looked at chaining. So we select the price. So you can pull out the variable with the dots notation, or we can use these columns. Remember, we can use a we can either use chaining or we can use the subsetting. So we have Melbourne. I've not imported it yet, so this won't work because I've not put the data. We can use it to select price, or we can do this, or we can use our square brackets. That is what I was trying to. Yeah, so now choosing features. So all those factors that contribute to that target variable are now what is known as our features. So in our case now, the feature columns are those columns that are used to determine the home prices. So these are our feature columns: the rooms, the bathrooms, the land size, the latitude, the longitude, right? For now, you see that our building model with only a few features. Later on, we'll see how we can iterate and compare and build with different features. So we select multiple features by providing a list of columns inside brackets. So you see what we did here: Melbourne, features, rooms, bathroom, land size, latitude, longitude, right? These are the features of interest, our input features that we're going to use to try and predict our target variable, right? So now, after defining these Melbourne features in a list, you see that we are now subsetting. So in that Melbourne data, just return the columns which are in these Melbourne features. And that will be my training data set, which is X, which I've highlighted here. But your target variable is Y, your training data set is X. So now this is a quick review of the numerical parameters of the data sets that are going to be our input features that we're going to use to predict our target variable. So that varies X dot describe here. So x dot head returns the first five rows. We've seen all of that. It rows, pattern, land size, latitude, and longitude. All right, so because of time, I think we'll stop here today. At least we have understood to a large extent the things you have to consider before going ahead to build your machine learning model. You have to consider your input features, your target variable. You have to know, is it a regression? Hey, we didn't do that. Okay, maybe we'll do that now. Is it a regression or classification task? Regression means you're trying to predict a value. But classification is like trying to say if your patient has diabetes or not. So you're not trying to predict a value. So based on that, this predicting a house prices, is it classification or regression? Is it a classification or regression problem?
A regression because we are trying
Thank
to
you very
predict
much.
a
Yes, house prices, which are numbers. So we've looked at classification and regression, very quick intro. We've looked at some basic steps you have to do before going into building your model. You have to understand your data, explore it, and understand the nuances in that data. And you need to talk to a domain expert if it's not your field. Then you also have to divide it into your training data and your targets variable. Where your training data, all the inputs which affects your target variable, which is in this case price. So on Friday, hopefully you guys will continue from there in building a model using decision trees to fit the model, and from there maybe also look at evaluation metrics, how you measure the performance of that model that you have built, which you can see here. But you can actually go advanced and have an insight. That's why I'm using Kaggle. So you can actually do some self-learning and even be above speed. Is that correct? Up to speed. Be ahead of speed. I feel those are just committed to grammatical blunders, but you get the gist. So you can go ahead, just go through. It's very, very simple and self-explanatory. And peradventure, there's something you're not clear, feel free to ask on the group chats. Right. So before we go, does anyone have any question?
Yes, I wanted to ask, like, what's the difference between like that NumPy and maths, like MATH?
The math library, right? Now, NumPy is a very popular framework among data scientists that is used for high-level computation. So when you are trying to build machine learning models, and the reason why is because it's built on top of C. C is a compiled programming language that is very fast, right? So you see how Python is running, and you just click, you run that code, and it returns. C is even faster than this. Some people say Python is slow compared to C. So because we need that speed, when you start building machine learning models like this, you see that they are very computationally intensive. So you need them to be as fast as possible. So that was the entire idea behind building the NumPy library, because it's built upon C, but all of that is abstracted away. So it is faster. When you're using NumPy to do your modeling, it's faster. So that is why you will not see anybody, you won't see anybody using math library to build ML models. You won't see it because you will sleep there, basically. Any other question? Or wait, Blessing, does that answer your question?
Yes, yes.
All right. Any other question, guys? All right. So in the absence of none, I guess this is where we'll call it. Um, bring the curtain to a close for today. So thank you very much, guys, for joining in. And please do the assignment too. You have two assignments. Let me show it again. Following this, following this guy, right? Let me just be back now. Hmm. Do the do the um assessment for how model works, and yeah, and okay, this one doesn't even have. So do the assessment for this basic data exploration. So explore your data is very simple. It's just calling dots describe and importing the data using pandas, reading the data with pandas, and describing the data. So it's very basic. So please do it pending ahead of Tuesday. Sorry, Friday. All right. So thank you guys very much for joining. See you guys. Abdurrahman, what did you mean by I did that last class? Was it the model building with scikit-learn you were referring to, or sklearn? I didn't hear you, Abraham. Yeah, I didn't still hear you.
I was referring to when we were talking about handling of missing values.
Oh, okay, yeah.
Yeah.
Done that. All right, now. So you guys can tell me if Paraventure Israel asks, you just start with building basic models for now. Build your first machine learning models. That's what we are meant to do next. All right, guys. So enjoy the rest of your day and have a lovely week ahead. Bye.